Out past Neptune, way out in our solar system, things are weird. Something's messing with icy objects, making them orbit in strange ways that the planets we know can't explain. Some think it might be a big, hidden planet 9, which someone suggested back in 2016. It's got astronomers excited. Interestingly, this has happened before. We found Neptune and Pluto because people predicted their gravity would be there before seeing them. Astronomers saw odd stuff with Uranus's orbit and in the Kuiper belt, which led to finding those far-off objects. Now, it's like that with Planet 9. We're using math to look for hidden planets again. Some scientists wonder if it's a planet that wandered into our solar system and got caught by the sun's gravity. Others think it formed with the other planets from gas and dust. If Planet 9 is real, it could be 10 times bigger than Earth and orbit the sun super far away. Astronomers have been working hard, using big telescopes and computer models to find it. After years of looking, doing math, and running simulations, they think they might have the best proof yet that Planet 9 is really out there. So, what did they find? And if we can find planets trillions of miles away, why is it so hard to see Planet 9, which is practically in our backyard? Even though Planet 9 was first talked about in 2016, the story goes back further, to when they found Uranus in 1781. Over time, people noticed Uranus wasn't quite where it should be. It sped up and slowed down in its orbit, like something was pulling on it. In the 1840s, two mathematicians, Urbain Le Verrier in France and John Couch Adams in England, thought that Uranus's weird movements could be from the gravity of another planet. They did a bunch of calculations to guess where this planet might be. It was a bold idea, looking for a planet just with math. Le Verrier sent his predictions to Johann Galle at the Berlin Observatory. On September 23, 1846, Galle and his assistant pointed their telescope where Le Verrier said, and bam, they found Neptune on the first try. That's the first time a planet was found by math instead of just stumbling across it. After Neptune, astronomers thought they knew all the big planets. But when they watched Neptune's orbit, they saw small problems, like with Uranus. It wasn't much, but it was there. Since they found Neptune by looking at Uranus's gravity, they wondered if they could find another planet the same way. That's how they found Pluto, over 80 years later. On February 18, 1930, Clyde Tombaugh, a young astronomer at Lowell Observatory, saw a faint thing moving way out there. It was a new planet, they thought. But Pluto was smaller than they expected, too small to explain the gravity stuff with Uranus and Neptune. That meant there might be more stuff out there. In 1951, Gerard Kuiper said there were probably lots of icy things past Neptune, with Pluto just being one of them. That area is now called the Kuiper Belt. They first saw something in the Kuiper Belt in 1992, when David Jewett and Jane Liu found a small, icy thing past Neptune. That proved Kuiper was right. As they found more stuff past Neptune, they started calling them trans-Neptunian objects, or TNOs. That's anything orbiting the sun farther out than Neptune. Finding Sedna in 2003 made things even weirder. Sedna is a big TNO with a really stretched out orbit. It gets pretty close to the sun but also goes super far away. In the years after that, they found even more of these extreme trans-Neptunian objects. There's something strange about how they orbit. Imagine throwing a bunch of marbles on the floor. Normally, they'd scatter all over. But if a lot of them clustered together in one spot, you'd think something was pulling them. That's like the TNOs. They don't orbit randomly, they cluster. If they were random, they'd be spread out all over the place. But their closest points to the sun tend to bunch up in one part of the sky. That's really odd and suggests something's affecting them. Plus, the lines of their orbits line up in a way that's unlikely to happen by chance. That's good proof that something, maybe a big planet's gravity, is pulling on them. The way these orbits line up is why people think Planet 9 is out there. Sedna, other TNOs, and this idea of a Planet 9 really got attention in January 2016. That's when Konstantin Batygin and Mike Brown put out a paper that made the idea stronger. They looked at the orbits of 6 far-off TNOs and said those orbits could be because of a planet nobody knew about. They said Planet 9 could be about 10 times bigger than Earth and orbit the Sun in a stretched-out path, super far away. Finding Neptune was quick. They saw it the first night they looked. But finding Planet 9 has been way harder because 1. It's super far away, maybe 10 to 20 times farther than Pluto. Being that far means it doesn't get much sunlight, so it's hard to see against all the stars. 2. Its orbit might be really stretched out. That means it spends most of its time super far away, where it's even darker and harder to see. 3. We don't know exactly where to look. That means searching a huge area of the sky, checking and rechecking to make sure we don't miss anything. 4. It moves slowly. Being so far from the sun means it creeps across the sky, so you have to watch it for a long time to make sure it's moving and not just a star. Because it's so hard to see, simulations are key. They let scientists model how things work and guess what might happen. The orbits of TNOs don't stay the same for long. Neptune's gravity messes with them, scattering them or even kicking them out of the solar system. That means TNOs are always changing, sometimes crossing Neptune's path. To learn more, a team ran simulations based on how the inner Oort cloud might have formed. The Oort cloud is a bunch of icy stuff way out there, surrounding the solar system. They picked TNOs with certain orbits and simulated 10,000 of them, one set with Planet 9 and one without. The simulations showed that Planet 9 could mess with the TNO's orbits, making them more stretched out and changing their angles. Without Planet 9, fewer TNOs get close to Neptune. With Planet 9, it happens more often. To make sure they were right, the team compared the patterns in the simulations with real data. They compared the simulations with 17 known TNOs and found that the model with Planet 9 fit the real data better. That means Planet 9 probably plays a big part in shaping those orbits. Soon, the Vera C. Rubin Observatory in Chile will start up. It has a powerful telescope that can scan the whole sky every night. It'll use what we've learned, like the Planet 9 stuff, to watch the orbits of far-off TNOs. If they keep running into the sun past a certain point, like the Planet 9 model says, it could mean we've finally found Planet 9. This cool telescope and new research could help us figure out what's really going on way out in the solar system. Maybe we'll finally confirm Planet 9. Also, the James Webb Space Telescope has been measuring how fast the universe is growing. The results show we might not understand the universe as well as we thought. If you missed that, check it out. And if you learned something new, please like and subscribe. See you next time. In 1951, Gerard Kuiper suggested there were tons of icy objects past Neptune, and Pluto was just one of them. This area is now called the Kuiper Belt. The first actual sighting of a Kuiper Belt object was in 1992, when David Jewett and Jane Liu found something they called 1992QB1. This proved Kuiper was right. As more stuff was found beyond Neptune, they started calling them trans-Neptunian objects, or TNOs. This is basically anything orbiting the Sun farther out than Neptune. Then, in 2003, they found Sedna. It's another big TNO with a strange, stretched-out orbit. It gets as close as 76 times the Earth-Sun distance and as far as 936 times that distance. In the years that followed, even more extreme trans-Neptunian objects were found. There is a distinct peculiarity in the orbital patterns of TN. Imagine scattering dozens of marbles on a flat surface. Normally you would expect the marbles to scatter randomly. If many marbles cluster oddly in a specific area, it might suggest a powerful force or factor pulling them together. This is kind of like the situation with TNOs. Their orbits aren't random. They're clustered. If they were orbiting randomly, they'd be spread out all over the place. Instead, they're bunched up in one area. This is super weird and suggests something is pulling them together. Also, the main axes of their orbits, that lines connecting their closest and farthest points, shows that the orbits are aligned. All this alignment is pretty strong evidence that something, like the gravity of a big, unseen planet, is at work. Building on the discoveries of Sedna I's and other TNS, the idea of a distant, Unidentified Planet 9 started to gain traction in January 2016. Astronomers Konstantin Badon and Mike Brown published something that cemented that idea. They looked at the orbital paths of distant TNS, suggesting the gravity of an unseen planet could explain this. They proposed that this hypothetical Planet 9 would have a mass about 10 times that of Earth and orbit the Sun in a highly elliptical path, ranging from 400 to 800 astronomical units. Neptune was discovered quickly. Astronomers found it on the first night of searching based on mathematical predictions. The hunt for Planet 9 has been much more challenging. For main challenges arise. First, it's far away. It's thought to be 10 to 20 times farther from Earth than Pluto. At that distance, it barely gets any sunlight, making it hard to see against the background stars. Second, Planet 9's orbit might be really stretched out. If so, it spends most of its time way out in the dark, making it even fainter and harder to spot. Third, we don't know exactly where to look. The area it could be in is huge, so we have to scan a lot of sky, rechecking everything to make sure we don't miss it. Finally, Planet 9 moves slowly across the sky. Because it's so far from the Sun, it crawls along compared to the stars behind it. This means we have to watch it for a long time to confirm it's actually moving and not just a star. With all these challenges, simulations are a big deal. They let researchers model complex systems and guess what might happen, even if we can't see it directly. The orbital paths of TN are not fixed. Over time, Neptune's gravity messes with them, scattering them or even kicking them out of the solar system. TNOs are always changing, often crossing Neptune's orbit. To figure this out, a research team ran simulations based on where the inner Oort cloud, a distant area of icy objects that surrounds the solar system, is believed to have formed. They picked TNOs that get closer than 30 astronomical units and have orbits ranging from 100 to 5,000 astronomical units, and simulated 10,000 of them. The team did 2 sets of simulations, one with Planet 9 and one without it. The results suggested that Planet 9 could affect the orbits of TNOs through something called the Runge-Lenz vector. This vector describes the shape and direction of an orbit when a force like gravity is acting on it. Planet 9 can stretch out these orbits and change their tilt. The simulations showed that without Planet 9, fewer TNS come near to Neptune. With Planet 9, these close encounters happen more consistently over a broader range of distances starting from about 16 astronomical units. To be sure, the team did a statistical analysis, comparing the simulations to real data. They accounted for any biases in how we observe things and compared the simulations to 17 known TNOs. The results strongly backed the model with Planet 9, showing a much higher chance, 0.41 compared to 0.34, that it matches what we see. This suggests Planet 9 plays a big part in shaping the orbits of these distant objects. In the next few years, the Vera C. Rubin Observatory in Chile will start running. It has a powerful telescope that can scan the entire sky every night. The hope is that by tracking distant TNOs, as well as recent studies including those proposing the existence of Planet 9, it can search and could see Planet 9 through patterns of close encounters with the Sun. This could point to where this planet's presence. This combo of new tech and research is looking good for figuring out the solar system and hopefully finding Planet 9. Recently, the James Webb Space Telescope measured how fast the universe is growing. The findings show is that something is wrong with our current understanding of the universe. If you missed this, be sure to catch up on this exciting discovery. If you learned something by watching this video, please do a like or subscribe for future things in the channel. Goodbye until the next video.